In this video, we will discuss objective questions on single point cutting tool, which are commonly asked in the university exam as well as in the examination of GATE. So the very first question, the tool life is affected by depth of cut, cutting speed, feed, all of these. So the answer is all of these. Your tool life is depend on all these parameter, that is depth of cut, cutting speed and feed. So here you can see. So here this is the workpiece which is clamped in the chuck and it is rotating with the with some RPM. Then this is the feed. So the tool is traveling in this direction. So how much the tool travels in one revolution, that is nothing but the feed, and this is the depth of cut. So your tool life depends on all these three parameters. Next question, a single point thread cutting tool should ideally have. The answer is 0 rake angle. So the single point thread cutting tool should have 0 rake angle. So here you can see the classification of rake angle. So rake angle is classified into positive rake, negative rake and 0 rake. Okay, these are some benefits of positive rake, that is reduce shear strength, then low power consumption, because as you are using the positive rake angle, so the tool becomes sharp. So low power consumption, low cutting force, then less tendency of built up edge, low cutting temperature and continuous chips are produced with the positive rake angle. Then negative rake angle, strong tool tip. So as the tool has negative rake angle, so there will be a more material at the nose. So strong tool tip, longer tool life, suitable for old machine, use of high feed and depth of cut and high productivity with negative rake angle. Then 0 rake angle, easy to design, easy to manufacture, easy to resharpen and easy for analysis. So these are some benefits of positive, negative and 0 rake angle. So a single point thread cutting tool should have a 0 rake angle. Next question, the surface of single point cutting tool on which the chips form in a cutting operation slide is called as. The answer is face of the tool. So here you can see the single point cutting tool and this portion is known as face of the cutting tool and the chip flows over this portion. So the answer for this question is face of the cutting tool. Next question, the point at which the cutting tool reaches beyond which it will not function satisfactorily until it is ground is called as. The answer is tool failure. So the tool failure is the point beyond which it will not function satisfactorily until it is ground. Next question, which cutting condition affects the cutting temperature predominantly? The answer is cutting speed. Okay, so which cutting condition affects the cutting temperature predominantly? So your cutting temperature mainly depends on the cutting speed. Next question, in metal cutting operation, maximum heat, that is 80 to 85% is generated in. The answer is shear zone. So here you can see the shear zone. So this portion is known as shear plane and this is the shear zone. Now the chips are shearing. That is why this portion is known as shear zone. So the maximum heat is generated in this portion. So in metal cutting operation, maximum heat, that is 80 to 85% is generated in shear zone. Next question, a cutting tool is single point, multi-point, both A and B, pointless. So the answer is both A and B. So your cutting tool can be a single point cutting tool like this, or it can be a multi-point cutting tool. Next question, in which of the following single point cutting tool is used? The answer is lathe. So the single point cutting tool is used in lathe machine. So here you can see the milling cutter. This is the milling cutter which is used in milling machine. Then this is the single point cutting tool which you can use over the lathe machine. This is the drill bit. This you can use over the drilling machine. And this is nothing but the broaches which you can use over the broaching machine. So in which of the following single point cutting tool is used? So the single point cutting tool is used on a lathe machine. Next question, following are the types of single point tools: solid type, tip type, indexable, insert type, all of the above. The answer is all of the above. So here you can see this is the solid type of single point cutting tool which is made up of a single material. Then this is a tip type of tool. So here you can see the tip is made up of different material and this shank is made up of some different material. Then this is the indexable insert type. So here you can remove the insert with the help of this Allen key. Okay, so this is the indexable insert type. So all these all are the types of single point cutting tool. So the answer is all of the above. Next question. It is the angle between the face of the tool and the line parallel with the base of the tool measured in a perpendicular plane through the side cutting edge. The answer is Backrake angle. Okay, so here you can understand the Backrake angle. So this is nothing but the Backrake angle. Okay, so this plane, the face of the tool, okay, that is inclined, right? So the angle between this face of the tool and the plane and this plane, that is known as Backrake angle. Next question. This angle is provided on the tool to provide clearance between the workpiece and the tool so as to prevent rubbing of the workpiece with the end of the flank of the tool. The answer is side rake angle. So here you can see the side rake angle or the end relief angle. So end relief angle or side rake angle. Okay, so okay, here also you can see the side rake angle. Sorry, this is the side rake angle. Next question. It is the angle that allows the tool to cut without rubbing on the workpiece. The answer is end relief angle. So here you can see the end relief angle. This is nothing but the end relief angle. So this face, again this face is also inclined. This is not exactly perpendicular and this is the perpendicular line. Okay, so there is some angle. This as this place, this face is inclined and this angle is known as end relief angle, and this end relief angle is provided so that the tool should not rub on the workpiece. Next question. The cutting tool removes the metal from the workpiece in form of. The answer is chips. So here you can see the chips are produced. These are the types of continuous chips. So the chips are produced during machining. Next question. Which type of chip form while machining of brittle metal? The answer is discontinuous chips. Okay, so there are three types of chips, that is continuous chips, discontinuous chips and the built-up chips. So while machining brittle material, discontinuous chips are produced. Next question. The angle between side cutting edge and end cutting edge is called as nose angle. So here you can see this is end cutting edge and this is side cutting edge. So the angle between side cutting edge and end cutting edge is known as nose angle. Next question. Tool life in orthogonal cutting is. The answer is less than the tool life in oblique cutting. So there are two types of cutting, orthogonal and oblique. So here you can see this is nothing but the first type. This is the orthogonal cutting where the cutting edge is perpendicular to the axis of the workpiece, and this one is oblique cutting where the cutting edge is not perpendicular to the axis of the workpiece. So tool life in orthogonal cutting, that means in this type of cutting, is less than the tool life in oblique cutting, because here you can see the maximum portion of the cutting tool comes in contact with the workpiece, and hence the tool life in orthogonal cutting is less than the tool life in oblique cutting. Next question. The cutting tool wears due to. So it wears due to edge wear, crater wear and flank wear. So here you can see this is the crater wear. Okay, so the wear takes place at the face of the cutting tool is known as crater wear. So crater wear occurs as a result of chip sliding along the chip tool interface, result of built up edge on the cutting tool. Okay, now this is the nose wear. So the nose wear occurs as a result of friction between the nose and metal being machined, and this is also one type of wear. So it occurs on the side of the cutting edge as a result of friction between the side of the cutting tool edge and the metal being machined. So the cutting tool wears due to edge wear, crater wear and the flank wear. So this is your flank wear, This is nose wear and this is the crater wear. Next question. Most of the metal cutting heat goes into the answer is moving chips. Okay. So most of the heat flows with the chips. Next question. Amount of energy consumption for unit volume of metal removal is maximum in. The answer is grinding. So the maximum energy consumption is in grinding as compared to turning, reaming and grinding. As compared to your turning, milling and reaming. Next question. Machinability of the steel is improved by the addition of. The answer is all of the above. So the machinability is improved by addition of sulfur, silicon and phosphorus. Next question. Only negative rake angle are used with the following tool material. The answer is diamonds. So negative rake angle is used in case of the tool which is made up of diamond. So here you can see the positive rake angle and the negative rake angle. Next question. In metal cutting, the built-up edge formation results in. The answer is improvement in tool life. So the built-up edge formation improves the tool life. So here you can see the built-up edge, the example of built-up edge. So the built-up edges form on the machine surface, then the built-up edge on the chips. Next question. Cutting speed is related to the tool life as. The answer is inversely proportional. So the cutting speed is inversely proportional to the tool life. As you increase the cutting speed, the tool life reduces. Next question. Flooding is the method in which. The answer is flooding is the method in which a low volume of cutting fluid is applied on the front of the chip. Okay, so here you can see this is the flooding. Next question. Hot hardness is an essential property for. So it is an essential property for the tool material. Hot hardness is an essential property for the tool material. Next question. Cutting power consumption in turning can be significantly reduced by. The answer is increasing the rake angle of the tool. So we can reduce the cutting power consumption by increasing the rake angle. So here you can see the rake angle. This is nothing but the rake angle. We can reduce the power consumption by increasing the rake angle. So as we increase the rake angle, the cutting tool becomes sharp, pointed, and hence less energy is required. Next question. The value of shear angle depends upon. The answer is all of the above. So the value of shear angle depends on the workpiece material, cutting condition, geometry of the tool. So here you can see the shear angle which is denoted by this phi. Okay, so the angle between the shear plane and the line parallel to the workpiece is known as shear angle, and it depends on the workpiece material of the tool, cutting condition, geometry of the tool. Next question. Continuous chip formation takes place due to. The answer is machining of ductile material. So whenever you machine the ductile material, continuous chips are produced. So as we have already discussed, three types of chips are there. That is continuous chips, discontinuous chips and the built-up edge chip. So while machining ductile material, continuous chips are produced. Next question. Discontinuous chip formation takes place due to. The answer is small rake angle and low cutting speed. So the discontinuous chips are produced due to small rake angle and low cutting speed. Next question. Segmental chips are formed during machining of cast iron. So cast iron is a brittle material, and during machining of a brittle material, discontinuous chips are produced or the segmental chips are produced. Next question. When the cutting edge of the tool is dull, then during machining, continuous chips with built-up edge are formed. So when the cutting edge of the tool is dull, then during machining, continuous chips with built-up edges are formed. Next question. The rake angle required to machine a brass by high-speed steel tool is. The answer is 0 degree. So whenever you machine the brass material, you have to keep the rake angle 0. Next question. The leap angle of a single point tool is usually. The answer is 60 to 80 degree. Leap angle is 60 to 80 degree. Next question. The average cutting speed for turning brass with high speed steel tool is. The answer is 60 to 90 meter per minute. Next question. Crater wear occurs mainly on. The answer is face of the cutting tool at a short distance from the cutting edge only. So here you can see the crater wear. So crater wear occurs at the face of the tool. So here you can see this is the face of the tool and the crater wear occurs at the face of the tool. Next question. In the relation Vt to the power n equal to C, the value of n for the carbide tool is. The answer is 0.2 to 0.25. Okay. So Vt raised to the power n equal to C. This is the relation to use the tool life. Okay. And here n equal to 0.2 to 0.25 for carbide material. Next question. While machining, which of the following improves the surface finish? The answer is increase cutting speed. So at high cutting speed, you will be getting good surface finish. Next question. Angle between side cutting edge and axis of the tool is known as. The answer is side cutting edge angle. So here you can see the side cutting edge angle. This is the side cutting edge angle. So the angle between side cutting edge and axis of the tool is known as. So this is the axis of the tool. Okay, this is axis of the tool and this is side cutting edge. So the angle between side cutting edge and axis of the tool is known as side cutting edge angle. Next question. The angle between the rake face flank of the tool and perpendicular line drawn from the cutting point to the base of the tool is known as. The answer is side relief angle. So here you can see the side relief angle. Okay. So this is the side relief angle. Next question. Small nose radius. The answer is it results in excessive stress concentration and greater heat generation. Okay. So as you provide a small nose radius, then there will be excessive stress as there is less material. So excessive stress will be concentrated there and greater heat generation will be there. Next question. The cutting fluid mostly used for machining steel is. The answer is soluble oil. So mostly soluble oil is used as a cutting fluid. Next question. In single point turning operation with a cemented carbide and steel combination having a Taylor exponent 0.25, if the cutting speed is half, then the tool life will become. The answer is 16 times. The cutting speed, then the tool life will become 16 times. Next question. The angle on which the strength of the tool depends is. The answer is rake angle. So on the rake angle, the strength of the cutting tool is depend. Next question. In metal cutting, use of low feed and high cutting speed is desired when the objective is. The objective is surface finish. So whenever you want to improve the surface finish, at that time you have to use low feed and high speed. Next question. The factor responsible for the formation of continuous chips with the built up edge is. The answer is low cutting speed and small rake angle. Low cutting speed and small rake angle. Next question. The angle between the shear plane and work surface is called as shear angle. So here you can see the shear angle. So the angle between shear plane. So here AB is nothing but the shear plane. Okay. And this is the work surface. So the angle between the shear plane and the work surface is known as shear angle. Next question. The rake angle required to machine a brass by high speed steel tool is. The answer is 0. Next question. The distance of a drill advances into the job in one complete revolution is called as feed. Next question. In order to prevent the tool from rubbing the work, relief angle is provided. Okay, so here you can see this is nothing but the relief angle. Okay, so here you can see the face of this flank of the tool. Okay, it is at some angle, it is not perpendicular, so this angle is known as relief angle. So in order to prevent the tool from rubbing the work, relief angle on the tool are provided. Next question, and this is the last question. Cast iron during machining produces, the answer is discontinuous chips. So as the cast iron is a brittle material, it produces discontinuous chips while machining. So these are very important 50 questions based on single point cutting tool. Please share this video with your friends so that they could also get benefited. Thank you so much for watching this video. Thank you.